1, we are Group 3, and this is our project proposal for BPH treatment. Benign prostatic hyperplasia, or BPH, is an age-related prostate gland enlargement that impacts 50% of men between the ages of 50 and 60. BPH is caused by the conversion of testosterone to DHT, which stimulates prostate growth. DHT increases the rate of cell growth but decreases the rate of cell death.
We wanted to develop a solution to BPH that improves on existing technology and allows for a long-term and treatment-centered medical device by creating a digital rendering, detailed proper specifications, using mathematical models to optimize the medical device, and altering design based on industry or medical professional and peer feedback.
That being said, we are proposing a long-term drug-eluting implant that uses IUD technology to release 5-alpha reductase inhibitors into the surrounding prostate tissue to maintain this urethral structure for patients. To take into account the different design constraints and patient specifications that we have to consider for our solution, we first looked at the time constraint. First, we want to ensure that the release of our drugs can prevent continued prostate growth over time. Additionally, our implant should last for at least 5 years in the patient to be considered long-term. Looking at patient population constraints, we decided to target early-stage BPH patients with prostate volumes below 60 cc's. For hormone constraints, we want to avoid additional adverse effects from our therapy. Lastly, we want to maintain costs that are competitive with the existing market. As a general design overview, on the left, you can see a digital rendering of our general implant design. With this, we have included 5 main technologies. We included IUD technology, which uses a drug reservoir with a slow-release system. Moreover, we will target prostate growth by releasing 5-alpha reductase inhibitors into the surrounding prostate tissue. We will also maintain a constant daily dose of 20 micrograms for 5 years via the microneedles placed at the end of each prong. To allow for urine flow, our design has a hollow center with 4 prongs to maintain tension. Finally, for the materials used, we will have a stainless steel coating to prevent erosion and calcification from the urine. To look more into the specifications and justifications of our design, we have chosen to maintain a prostate volume between 15 to 60 cc's because we found that the normal prostate size is about 15 to 30 cc's, with a cutoff of early stage BPH at about 60 cc's. We will also place our implant below the bladder neck to prevent retrograde ejaculation and permit normal bladder control. As for the size, the length will be between 25 to 29 millimeters and a width of 9 millimeters, as this approximates the urethral length and width.
As part of our prototype and in further defining our treatment plan, we decided to create a mathematical model in MATLAB that would represent the prostate and how our drug interacts with the organ. So our model's purpose is to determine how much drug should elute from our device to maintain normal prostatic DHT levels. For our model design, we consider the prostate to be a closed system with a constant supply of testosterone and a constant rate of supply of our drug. Within the prostate, testosterone is constantly converted to DHT through an enzyme called 5-alpha reductase. We made a number of simplifying assumptions based on a paper that also modeled the conversion of testosterone to DHT within the prostate. Our first assumption is that the testosterone levels remain constant in the prostate at any given time through a constant supply from the blood. We're also assuming that our drug elutes from our device into the prostate at a constant rate. Our third assumption is that testosterone is converted to DHT at a constant rate through an enzyme, and we define this variable as K. Now, based on that third assumption, our fourth assumption is that the initial testosterone levels are directly proportional to the initial DHT levels in the prostate. Lastly, we're assuming that DHT is directly correlated with prostatic volume and growth. This is because DHT causes a series of downstream signaling that causes the synthesis of proteins that increase cell proliferation and also decrease cell apoptosis. So here we found that the normal values of K and initial concentration of DHT in the prostate for human males, and in using these values and assumptions, we were able to develop a representative series of equations for the model. Looking at some arbitrary parameter values based on average male initial DHT concentrations in a time period of 192 hours, our results are shown here. The left graph shows the exponential growth of the concentration of DHT without any drug. On the right, you can see that with our drug, as the drug accumulates in the prostate, the drug is able to decrease the production of DHT. Eventually, after 2 days, the drug is able to maintain a set concentration of DHT in the prostate. So here we plotted both of those graphs on the same graph to show the effects of our drug more prominently. Using the parameters from this example, we're able to maintain a normal DHT concentration of about 2.5 nanomoles per liter. The parameters can be changed to reflect different patients as well. Using this information, our drug elution rate is determined to be 0.024 nanomoles per liter.
If any of the assumptions are found to be untrue, our model would fail. Also, it would fail if the release of 5-alpha reductase inhibitors is outside of the prostate or the level is too high, or if there is infection after insertion of the implant, and if there is failure of the components in unison or succession. If there is stent failure due to excessive tissue proliferation, persistent pain, or migration of the device. Why choose us? Because we provide a long-term solution, we provide localized drug delivery, and our model helps with BPH-related symptoms. For example, it prevents hair loss and it maintains prostate size, and it provides convenience and competitive costs to what's available out there. Thank you so much for listening.